With over 7 billion in economic output and 18,000 plus jobs in Montana's mining industry, mining is a massive economic driver in Montana. We heard earlier from Philip Britton that AI is touching every aspect of our lives. This includes mining. How is the industry evolving to meet next generation's demands? Let's welcome my good friend and executive director of the Montana Mining Association, Matt Vincent, with John Medish, director of the Montana Bureau of Mines and Geology, and founder of Quantum Strategics, Luke Moritzen.
Well, thank you. It's exciting to be here. We really appreciate the Chamber asking us to come up here and have a discussion on critical minerals and next generation demands. And we've got some great guests here. I'm very excited to hear these two gentlemen educate us all. So critical minerals are a list of about 56 different elements. These guys are gonna talk about, John, of course, more broadly, Luke more specifically, but everything that we've talked about here with regards to energy and data centers and technology depends on minerals and vice versa. I mean, I think it's a real circular thing here, and so excited to have this conversation. Relative to, if you've been paying attention, China controls over 60% of the mining of critical minerals and over 90% of the processing. And they've named some specific minerals just over the last year: gallium, germanium, antimony, and graphite, as well as they kind of left the door open on heavy elements that are necessary in everything from defense to quantum computing and things in our everyday lives. The vibrations on your phone when it rings is made possible by rare earth magnets. And it's only going to get bigger. The exciting news is that Montana can supply, we have 100% of those restricted elements. We have about 70% of the total list of elements. And so I'm going to start off by asking these two gentlemen to introduce themselves with some information that the audience hasn't already seen in their bios. So, John?
All right. Thank you, Matt. Yeah, I'm John Medish, as Matt said, director of the Montana Bureau of Mines and Geology and state geologist. I was born and raised in Butte, went to MSU, go Cats. Got my master's at Montana Tech, so go Diggers. And then I got my doctorate at U of M, so go Grizz. All right. And I'll talk about, the advantages of the Montana University system later, but, growing up in Butte, my dad started out mining, actually, was one of those initial workers on the Berkeley pit in Butte, and eventually ended up owning a bar, which I worked. So in full disclosure, I've got a lot of bar stories if you want to talk about that. But so I've been with the Bureau of Mines, again, my undergraduate at MSU, and then while I was working on my graduate work at Montana Tech, started working for the Bureau of Mines, did my thesis through there, and nobody told me to leave yet. So after 34 years, I'm still there. I've been director for the last 12 years or so, and I got to say, the career has been wonderful because working in Montana, you focus on Butte. I did a lot of Superfund work in my early years with mine flooding, things like that. But as I grew professionally, I got to see a lot of what's going on in Montana. Mainly groundwater is what I worked on, but economic mineral deposits and things like that. So it's been an exciting career, and I think I've learned a bit. And the Bureau, just so you know, was started in 1919. It's a non-regulatory agency within the university system. And again, immediately publications, it was basically set up for the mining industry to start publishing reports and maps and things like that, even doing assays. So all the reporting early on was focused on mining, but then very quickly it got into the other economic resources in Montana, oil and gas, different types of mining, even mining methods, placer and things like that. But after 100 and some years after it has expanded into groundwater, earthquakes, things like that. But it still stays true to its core mission, which is to map and report on geologic resources in Montana. So we're still at it. Again, keeping that non-regulatory source of information for whatever decisions have to be made about mining, reclamation, and things like that.
Thanks, John. I can vouch for how important the work is that they do. We include them in our work all the time, and so thanks, John, for everything you're leading up there at Montana Tech. Luke.
Okay, good morning, everybody. Luke Moritzen. I'm from the Bozeman area. I grew up in Eureka, Montana, and I'm also a Bobcat, graduated from Montana State in mechanical engineering. My first job as a engineering grad, I always wanted to go on and get my master's and my PhD, but I was so sick of taking tests and jumping through all the hoops, and I was like, man, I just want to make stuff. And so I figured I'm just going to go for a couple years and make stuff. And so I took my first job, and we were developing cryogenic technologies for defense applications. So it's like where I like to say I learned how to spell cryogenics there. That quickly led to a startup. And pretty soon I was off and running and getting all my education there that I would ever need or want. So that kind of took a path. So I started Montana Instruments. Montana Instruments is based in the Gallatin Valley there, and we develop cryogenic systems for quantum computing. We had the I guess honor and pleasure of placing systems in virtually every company and every laboratory in the world that's studying quantum physics right now. So global company and just a fantastic team that was built there, and we were acquired about 2 years ago by Atlas Copco, and that's been a really fun process and a really good process. And maybe one interesting thing about Montana Instruments that you might not know is in 2016 we were placing systems all over the world, but then there was this article in the New York Times that said, Einstein proved wrong, and spooky physics, and Einstein proved wrong. Well, it turns out I started reading the article, and I was like, hey, that's our customer. And so for years, Einstein had struggled with this idea of entanglement. And the math seemed to say it was true, but he couldn't accept it, the reality of it. And so then our customer in Netherlands, Ronald Hansen is his name, he actually was the first one to demonstrate the repeatable empirical experiment in our instruments of entangling photons, sending them some distance away and measuring it. So proved Einstein wrong, and now everybody's doing it all over the world. Now it's like no big deal. It's everybody's doing it. So this, and then my time advising the White House, I got the opportunity to kind of see the quantum industry from a higher level, but also get the perspective that what I had been doing was developing supply chain pieces for quantum computing and realizing that has a major impact in the national security of the nation. So what I wanted to do next really was I would like to help to transform the quantum supply chain for the U.S. and its allies. And this has a strong tie back into national security, and I also see a strong tie of what Montana can do in that area. So I have two companies now that I'm building. One of those companies, and I'll end here, one of those companies is starting out in Boston. We're going to bring all the manufacturing back here to Montana, though. And but what we looked at our business risks, we looked at all our risks. The number one business risk that we have is one of the materials that we have to buy a lot of, and we can get it from China at, or we can buy it from one other place for like 5 times the price. So if that China supply somehow went away, which there's a good chance that it could with all the geopolitics that's going on, we'd be in a lot of trouble. So I have to solve that. And that's one of the reasons that my attention has gone to not only that material, but it's just one example of many materials that we have a supply chain dependence on that we have to solve.
Awesome. And, you know, I think just to underscore it, I mean, obviously Luke's going to talk about one element as it relates to quantum computing, but one that we can all relate to, which is on the Department of Energy's list, is copper. We were provided a statistic by one of our keynote speakers at the last annual meeting that we had from Ivanhoe Electric that up until now in time, and that means like from the beginning of civilization, there's been 700 million metric tons of copper produced. Just to hit 3% GDP with all of the new applications that we're talking about, data centers, quantum computing, over the next 20 years, we will require that much more copper. So all the copper that's been mined up until this point is going to be required for us to continue on a 3% growth pace through the next 20 years. And that number does not include the energy transition. So it's actually much higher than that. And so there's been a lot of discussion and focus on critical minerals at the federal level. We're here in Montana. John, there's nobody better than you to tell us, you know, what critical minerals does Montana have, and how can you see us playing a role in this demand?
Yeah, you know, I'll start out by defining what a critical mineral is, and sometimes, you know, what it isn't. There are 2 parts of the definition that you keep in mind. One is the commodity or element of interest is in low supply or no defined reserves in the U.S. And that's very much market driven. Critical minerals, everything I talk about today is going to be market driven. An example of that is zinc. Zinc is a critical mineral on the list. It doesn't get mined in Montana anymore, doesn't get mined throughout the U.S., not because we don't have any, we just don't have any reserves set back because the market hasn't been favorable for zinc for 40, 50 years. So it becomes critical. The other part of it is that the supply that we do have of a particular element or commodity is foreign and threatened. So again, rare earth elements is probably the low-hanging fruit. And as Matt said, I mean, China is mining and producing 80–90% of the zinc, of rare earth elements, of germanium. So they control the market. And again, like I say, it's market driven. So the market is driving up the cost, making it unavailable to the U.S. because of political issues. And so that's strike 2 that puts it on the list. Copper is not. Copper is not on the list, on the critical minerals list, not because it's not in demand, but because we have reserve estimates. You know, Butte has a 20, 30, 40-year reserve estimate. So copper has been supportive and supported by the market for the last 20, 30 years. But as Matt points out, that can change. And they reevaluate this critical mineral list every couple of years and evaluate, do we have reserves identified in the U.S., yes or no, and are the foreign supply threatened? So that's what critical minerals are. And again, I think the thing to keep in mind, it isn't because we don't have any. So that's where we come in, is, well, do we have any? And the short answer is yes. I mean, there's deposits around Montana that are known. You know, we have ore deposits. We've been mining for years, for decades, for more than a century. So many of these elements are known to exist. We know about the deposits. They've been sampled in the past. Sometimes they've even produced some of these, what are now critical minerals. Germanium, for example. Butte was a huge producer of that. Butte was a world producer of zinc up till World War II. So, but the market has made that kind of go away for us. So we're aware of a lot of these things, but we haven't paid much attention to them in decades. So ore deposits, especially southwest Montana, Helena, down south to Phillipsburg, on over to the Idaho border, south, Beaverhead County, all the way around, back up Whitehall, Boulder Batholith, all these granitic intrusives, very high prospect and potential for base metals, and of course these critical minerals that go with it. So, and we know that because of past production. Bureau of Mines is a pack rat when it comes to records and data related to mining and geology. And so all of these mine records that we've accumulated over the last century, 30 years ago, we used them to identify abandoned inactive mines for environmental assessment. In the last 5 years, we've been using those same records and updated the data to include critical minerals and things like that. So that's one particular area, geographic, southwest Montana, central Montana, what we call the alkalic belt, Highwood Mountains, and up in that area is known deposits for mainly gold and silver, Zortman, Landusky, Cascade, different places, Neidhart, that you might recognize for gold deposit. But we know that that type of deposit also has these critical minerals. Montana-Idaho border is another area that's called an alkalic belt. Extends from Utah, Montana-Idaho, and on up into British Columbia. Well-known deposits, particularly for rare earth elements, but also zinc. So we're pretty much aware of these and have been for decades, I'll say. But over the last 4 or 5 years, this emphasis for getting past that next step. We have this regional information about these deposits. The next step is to start characterizing them a bit. So that's what we've been working with Department of Defense, U.S. Geological Survey, and Department of Energy funding to start sampling these deposits again. Now that we have a different set of minerals that we want to look for, now we can start sampling those. So that's what we've been doing for the last 4 or 5 years, and we'll continue to do that. The other big opportunity in Montana, though, is going to be the waste. There are large waste piles from past mining. Again, I mentioned Zortman Landusky is the poster child, but it was developed for gold, cyanide heap leaching, underground cyanide solution. Nothing else was extracted. So the waste has remarkable, very remarkable concentrations of rare earth elements and other critical minerals. So it's a whole new day in terms of looking at these large waste piles for extraction of critical minerals. Beal Mountain, Butte itself, MR is retooling a lot of what it does, copper and moly, but now the technology is allowing us to look at zinc again. Again, they're doing zinc extraction. We've been working with West Virginia University over the last 4 or 5 years, and they've got an extraction process for getting zinc out of Berkeley pit water. So the technology is changing, and so the opportunities are changing considerably. And I'm particularly looking forward to reprocessing a lot of waste around Montana. I think that's going to be, the permitting is easier, the good neighbor opportunities are much better, and again, I think it's going to be a lot of good opportunities there. The third one I'll mention briefly that you may not think about is coal. Montana has the largest coal deposit in the U.S., millions of tons, and whether you like coal or not for energy development, it has significant quantities of germanium in it. So North Dakota, South Dakota, another one of our projects is looking at germanium, rare earth element concentrations in the coal beds of southeast Montana and on up to Helena. So if coal continues to be processed at Colstrip, things like that, that gives us an opportunity to maybe start extracting germanium and some of these other rare earth elements. So those are the three areas where we're going to be looking and have been.
Thanks. Thanks, John. And one additional one that I think you skipped over that we should include is on the critical list, we've got the nation's only platinum group metal producer, and we could have a whole separate discussion on the geopolitical pressures that are affecting Stillwater right now. And we're along the lines of that permitting piece. That's kind of what we're focusing on, is how can we get more of these critical minerals out of the existing permits that we have, be it cobalt out of the newly permitted Black Butte project, or chromium or nickel out of the Stillwater deposit. It's in recognition that we're second to Zambia in the world right now for the amount of time it takes to get from exploration to production on metals, at 29 years. So we can't, even though we are continuing to identify these deposits, until something significant changes with that permit time frame, we got to focus on the permits we already have and the waste deposits that John mentioned. And I know you kind of alluded to it in your intro, Luke, and we'll get into it here, but why don't you tell us, in your opinion, how important it is for America to not only be filling a void in supplying its own critical minerals, but also leading the technology and how it's refined and processed into the forms that we need. We already alluded to the fact that China controls 90% or more, nearly 100 in some cases, of the refining and processing of certain critical minerals.
Yeah, so I guess I can already see that there's kind of two industries here. There's a mining industry, and it's like, how do we get the stuff out of the ground? And it sounds like maybe even the bigger problem is, how do you get a couple pieces of paper across the desk, right? So those are real challenges. So there's a mining industry, but then when you look at the path of a material from its raw state out of the ground all the way up to its final form, I'm much more familiar with the challenges and the needs at the far end, and that's actually more of a high-tech industry. I think there's an opportunity and this is where I see Montana can play a really good role. This is just good old-fashioned American innovation again. This is looking at the processing steps. And for instance, you might have a material that goes into an application. Well, it needs to be in some final form, some geometry, some shape, and some size, right? So there's like a forming or an atomization process of that. That's one of the final steps. But just right before that, there's an alloying process, or in some cases, there's a crystal growth process, where you're trying to get the right rare earths in the right quantities. And then, but and there's always some impurities, right? So what are those impurities? How much impurity is there, and which impurities are there? That really matters to get the final properties. Then you have to be able to test those properties. In some cases, and in the case of quantum computing, these materials are used at very low temperatures. So you have to be able to test those properties at low temperatures. So I'm describing all this so you can kind of get a sense that that's basically a high-tech industry. And just because those materials were made some way, decades ago in China, doesn't mean that we would necessarily have to make the materials in the same way today. We don't. I think materials development is like a brand new frontier. I'm very excited about it. I think we are the materials development as a industry is in its infancy, I think. So this is an area where there's a lot of innovation can be applied. And I'll highlight another point here. I think one of the challenges with this that isn't readily realized is, you take something like lithium or even copper. Okay, we need a ton of that, right? And there's big industries that are dependent on that. Those problems are going to get solved, I'm confident, right? It's the niche market materials. It's the things like that that are, for instance, I'll pick one that I'm familiar with. Holmium is a rare earth. It's alloyed with copper, so you get holmium copper. It has really specific properties at low temperature. No other material has that. There's one other replacement. It's not as good, and it would be more expensive. 90% of the supply comes out of China. And there's about, there's one mine in Mongolia where 100% of the world's supply, about 10 tons a year, that's not a lot, about 10 tons a year comes out, and it's 100% Chinese controlled. So obviously this is a problem, right? And we do have stockpiles in various places throughout the world, so there's a timeline there that, in the worst case. But to me, the biggest threat and also the biggest opportunity is to take control of those final processing steps. We can go out and buy the material. We can get holmium. That's not a big problem, at least in the short term, right? Relatively short term. It's bringing that holmium into a final state that you can actually use it that is critical, and then and to do it at a price that you can sell it in the market. That's the challenge. These are niche markets. They're not huge. But for instance, in that material, if you don't have that material, you don't have a quantum computer functioning. So it's a choke point. It's a choke point for every single quantum computer that exists today. So from a national security perspective, that's a really big deal. We have to solve that. But if we were to just go out with like private dollars and an ROI, it's not feasible. You can't make the investment and produce the material and then come onto the market and sell at a price where you can pay back that investment. You just can't. So this is an area where there has to be a public-private coordination. And there's motivation on the private industry to do that. There's many good reasons to do it. But if it's going to happen, and I think this is just one example, there's probably many examples, and I'm becoming more aware of those examples. That there's a public-private partnerships is how we're going to do this, and I also think the answer is partly there, but the answer is partly in new technology, because I think one of the opportunities for us to look at is, okay, so maybe you make one material with this infrastructure. What other materials could be made with that same infrastructure or something very similar that could be retooled? And now you're reaching across many niche industries with largely one infrastructure investment. And that's how I'm viewing it, and that's what I'd like to see that kind of innovation exist here in Montana.
Awesome. Well, we'll be discussing critical minerals at our annual meeting this year. It's going to be the theme of it, and we've also got the benefit of being able to continue working with John and Luke as Montana plays host to a third critical resource summit later this spring over in Bozeman. We've done this before when Montana arguably had the corner on this. Anaconda Company was the fourth largest corporation in the United States, and their slogan was "From mine to consumer." They controlled the same supply chain circular that China is currently enjoying, and with our world-leading environmental standards and labor standards, I think we've got a lot to bring to the state again if we can figure out how to do that 2.0. We had another question, but we talked a lot about these things, and so anything else you guys want to say before we wrap up?
Well, maybe I'll just say this too. I've got, I set up Quantum Strategics for the purpose of helping to transform the quantum supply chain for the U.S. and its allies. So as we do that, we're either acquiring companies that make sense, or if the technology doesn't exist, then we're starting companies. So two of those are coming up now. I'm already looking at the need. Like one of my greatest needs today and in the future will be the entrepreneur or that CEO, that person who wants to step into that role and lead some of these companies. And so that person could come right out of school, or it could be somebody that's working in industry now, but I see that's going to be one of the most critical needs.
John?
Yeah, just very quickly, I think one of the challenges, other than what we've already discussed, is going to be workforce development, because we haven't been doing this for a while. So again, shout out to the university system for having mining engineering, metallurgy at Montana Tech, environmental engineering, because it's not going to be just digging something up and shipping it off. We learned a lot from our past mistakes in terms of environmental impacts. So new regulations, new challenges on getting a mine going in Montana. It takes about 10 years, but there's a lot of moving parts to it. And we don't have, geology graduates are the lowest they've ever been. Engineering students are just not enrolling anymore because the market wasn't there for them either. But that's changing pretty rapidly. So the system has to respond. And I was at a workforce in DC last year, and trying to marry academia with industry and government was the challenge that they put back to us. There are a lot of mining companies who say, just give me somebody with a bachelor's, I'll train them here. And they took that a next step farther on some universities, is to have industry start teaching classes on campus so that they can students can get exposed to their profession while they're working on their degree. So things like that to make the education go faster, permitting go faster, and things like that, and of course supply. Montana has a great university system, and just like wheat, we can grow enough and export some and keep the best here.
Go Diggers, go Cats, go Montana. Thank you, guys.
What a continued fascinating discussion about how everything we're doing in business in Montana moves from one business to the other business, one industry to the other industry. The idea that workforce development is still a critical function across all industries. The idea that as we want to advance quantum physics and quantum technologies, we need data centers, but we also need minerals, and we're the treasure state. And just continuing to really explore that, as we go through this, we want to thank a few more of our sponsors before we get to our next panel. The corporate sponsor, the copper sponsors are Enbridge, the Montana Bankers Association, the Montana Grain Growers Association, Sandfire Resources America, TDS Fiber, and UBS. And we are just continuing to thank them and appreciate them because they make these events happen, and they get the speakers to the table and give us an opportunity to discuss it.